Hello everyone, I'm Anupama, and you might be wondering why do I have a fucking motorbike behind my back? That's because I have a history of bad ideas. And to top it all off, this is gonna be the dumbest one of them all. So I decided to make a bike simulator with manual shift and analog throttle, rear brakes, analog leaning, front brakes, and also force feedback. And I'm making it because I freaking love bikes. Also, it sounds kinda cool. So you're watching Engineeroids, and let's build it now. Step 1, get a bike in your room, which is totally completely very normal, like everyone does that. Step 2, enjoy some vroom vroom. Step 3, making this shit work. See, this bike is not electric, meaning we cannot just put in some wires and expect it to work. So we're gonna put a bunch of sensors on it to get some values from these levers. And lucky for us, most of the mechanics that we'll be working on are just simple angular displacements. So we'll start off with these four because they are quite similar and easy. For this, we'll need an IMU, or a bunch of them. These IMUs can measure the acceleration and the rotation in the X, Y, and Z axis. A microcontroller, a motor driver for the haptics, some indication LEDs, and a prototype board that we'll be using to make a motherboard to connect all the sensors. And since it's my brother's bike, I was advised to not put any holes in it. Well, I was not even advised, I was given a thread. So we'll be using Velcro straps to attach the sensors to the bike. And now my hands are more greasy than fucking grease itself. And then I started working on the motherboard, which took me an all-nighter, and I hated every single second of it until it turned out to look like this. So we have a microcontroller, a motor driver, a notification LED, and headers for the sensor. And now it's time for the step 4, which is to write the code. And that would be easy for me, it will only take about 8 days. And we have a problem. These sensors work on I2C, and I2C doesn't work well on long wires. So if we put the ESP32 at the top, we won't be able to get the reading from the sensors at the bottom, and the other way around. So my approach is that instead of using just one ESP, we use two of them, and then establish a wireless connection between them to transfer those values. And now it's time to test it. We have one of our ESPs connected to the CL monitor, and the other is not yet connected. So if we plug in the battery, we should see some values on the monitor. So we plugged it in, and we have our values. And then I took the readings from all the sensors, hooked everything in, and now it's time to test it. And now it's time for the brake and the clutch mechanics. So if you actually paid attention in your high school, you might have heard of a term called the Hall effect. So basically if we put a magnetic field near a conductor, it generates some voltage. But how do we measure that voltage, you say? Well, I don't know. So we're going to use these Hall effect sensors. And since the Hall voltage is proportional to the magnetic field strength, and the magnetic field strength is inversely proportional to the cube of the distance, we can estimate how far the magnet is from the sensor. So this is our setup. We have a magnet attached to the lever and the sensor attached to the grip. And when we pull the clutch, the sensor detects the magnet. And the same goes for the brakes. And now it's time for the most complex and the most important thing for the immersion, and that is leaning. Well, I initially thought it would be simple, we just make two armbands, get some values and put them in our code. But then I realized that the gyroscopic readings were quite inconsistent while leaning, and I cannot judge the leaning solely from this data. So I used a technique called the sensor fusion, and basically it combines the accelerometer values and the gyroscopic values to give more accurate results. And then I spent the next week calibrating and coding, and now it's time for the test drive. So that was the video. I hope you liked it, and I'll see you in another. Also, if you want to make one for yourselves, please don't. You'll be happy.